Okay, we started going over GUIs in Java, and in my mind, the most confusing thing that we talked about last week, most confusing for a lot of students, seems to be the idea of an action listener. And in the example that I went over last time, we went over 3 ways that you can set an action listener. First of all, what is an action listener? An action listener is the object that contains the code that is to be performed when the user does some action to the form. And in the examples that we gave, the action listener was for clicking a button. So we associated to a button an action listener. So what are some of the rules that we have as far as action listeners go? First of all, action listener is an interface. And when we say something's an interface, we mean that it must contain any class that implements that interface must contain the methods that are defined in the interface. So in our case, action listener interface has one method in it, and that is action performed. That accepts object. I believe this is a void. Accepts as an argument. An argument of type action event. And then it does something with it. So to make anything an action listener for any element on the page, the object that's going to be the action listener must contain this method. We looked at 3 different ways that you could create an action listener for a thing on a page. One method is it could be the JFrame itself. So in the first case, we saw an example where we had the JFrame serve as the action listener for the button that's on the JFrame. In order to do that then, that JFrame whatever it is going to extend our JFrame, let's say. It's going to extend JFrame and it's going to implement action listener. That means in the JFrame class, we need that action perform method. And in that, we put the code. All right. So the very first example, we did that. That kept things very simple because we had our JFrame that contained all the form controls, and it also contained the code that gets executed when we click the button. So that was this example here. All right, our JFrame that we're calling first GUI extends JFrame, and it implements action listener. It's exactly what I said here. It extends JFrame and implements the action listener. That means that we need a method in the JFrame class, in our first GUI class, that is action performed, that accepts an action event. And here it is, public void action performed action event E is the argument. How do we assign that then to the button? We'll do something like this. Whatever our button is called, I hate how it auto corrects. So we're going to associate this object, that is the JFrame object, with the action listener for that button. And that's what we do in this example. We implement the action listener interface. We have our action perform method that accepts an action event as an argument and returns nothing. And then we say our button add action listener this. This means this particular object that we've created when we create a first GUI object in the constructor. So it's going to be its own action listener. Now, if you notice, it gets past an argument action event. What is the purpose of that argument? That adds information about what exactly happened. First number in the range of IDs used for action events. The last number indicates if a meaningful action occurred. So on. We can use those sometimes to get greater detail about what actually just happened. In our case, we're talking about clicking a button. So we know what happened. The user clicked the button and we don't need any information from that action event, but it is available in some cases where we would need it. That's the simplest example. Next one we have is to create an inner class. What's an inner class? An inner class is, just as the name implied, a class inside a class. So if we had public rFrame extends JFrame, we have the braces. We have all the code that's in the class. Then we have, in between the starting and ending brace, we have defined our own object. We can say something like, well, we can make it public or private. It doesn't really matter. Public. Convert data or something like that. And that will implement ActionListener. And because it implements that interface, it needs an action perform method. That accepts as an argument an action event. And then we have the code that happens when that event happens. Again, in our case, clicking on a button. How do we add that to the button? We would say button. Add action listener. New convert data. We can plug it in because this is an action listener. That's what we did in the second example here. There's two buttons, so we actually did it a couple ways. Here we have defined at the bottom, but inside the curly brace, we have our class, public class, implements action listener. We have our action perform method, and then we have adding to it. Button convert equals I'm missing it. Oh, here we go. Button convert equals add action listener new C to F. The last way is by an anonymous class, and that's what we do here. Where we don't define a new class, we define as part of the action listener event a new class, but we don't even bother to give that class a name. This is called an anonymous class. And we do it like this. We say new action listener, and we specify the braces for that. Inside that, we have, as always, the action perform method. We can do that because this is an action listener. So I hope that clears it up. This is really important. And in the case of that second example, we actually had two action listeners because we had two buttons. All right. And those buttons, each of the button had its own action listener to do something if it was clicked.
Oh yeah, I think you already answered what my initial question was going to be. So every button needs to have an action listener.
It should, otherwise nothing will happen when you click it.
Right. You kind of already answered that was my original question, but you kind of already answered it.
Okay. Do you have any further questions?
Well, as we go along, I might. But so far, I think I'm getting it.
Okay, excellent. All right, so we're going to go to another. We're going to look at, by the way, in this one, we're going to look at something we didn't have a chance to look at last time, and that is how to do a layout. So we'll compile everything. messed something up. Java 43. And Java 57. And 2. I am going to re-expand that zip file. I'll bet you I accidentally typed something in. Because I know this worked. We used it last week. We're getting an error still. Okay, let's try. Okay. There we go. I don't know what went wrong. I'll bet you why I accidentally hit a key and then lost track of where I did that. Okay, so let's run this. All right, notice how this looks. We have a label, a text box, and then two buttons side by side. How did we accomplish that? Well, one thing that you should know is that panels are by default oriented vertically. Or I'm sorry, I think I said that wrong. Panels are by default oriented horizontally. But here we change that. We say that this panel P1, or this panel P, is oriented vertically. That's what this means. It's oriented vertically. we add these three things. We add label 2 or label temp, text temp. That adds these two things. Then we add P2. And what is P2? P2 is a panel that contains our two buttons. So P2 is oriented horizontally because that's what panels are by default. We changed the orientation of P, but we did not change the orientation of P2. So these are stacked vertically on each other, but within P2, they're stacked horizontally. And then we have the results underneath that. So as I type something in, we get the results. All right. If we said this was to be aligned on the x-axis, then everything would be aligned horizontally.
That makes sense just from like, if you know, from like the coordinate X and Y axes, depending on
Exactly.
this.
Here, things are oriented horizontally. Now, we're not going to spend too much time worrying about the exact layout as long as your layout is functional. So we can put panels inside of panels. That's how we can have this last panel, or the panel for the buttons rather, or within that panel, the things are oriented horizontally because we did not change the orientation of that panel. Now there's another way that you can set this, and this is called border layout. And with border layout, you define things according to a layout like this. Now, let me Google it real quick. I'll show you better than I can draw. We have the north, west, center, east, and south area that we can orient things. So here, we uncomment this out, comment this out. We set a border layout. We put the label for the temperature in the north portion of it, the text for temperature in the center of it, or the text box for temperature in the center of it, and the buttons in the east portion of it. So we compile this. And we get north, middle, east. I think we put then the result in the south. So that's another way to do layouts. Now I'm not going to enforce that you have a beautiful layout. I don't want to spend the time. I don't want you spending the time to get a perfected layout, but do spend the time to make sure that your layout is logical and understandable. Next thing we're going to cover today is a little game that I wrote in Java. And this is a high-low game. The high-low game, I use this in other classes, so maybe you've seen it before. But the high-low game works like this. We roll 2 dice. All right. So the range, if you roll two 6-sided dice, is the range can be somewhere between 2 and 12. We predict if it's going to be high being defined as 8 through 12, low being defined as 2 through 6, or exactly 7, which is when the total of the dice equals 7. So if I rolled a 1 and a 5, that would be low or 6. We predict that and we win if we get it right. If we predict high and it's high, we win 1 point. If we pick low and it's low, we win 1 point. If we pick 7 and it's 7, we win 4 points. Now, the odds are stacked against us in this game, as they are all gambling games, because 7 has a 1 out of 6 chance of happening, and yet we're only getting paid 4 points. And if we're wrong, then it's minus 1 point. So we're getting paid 4 to 1, but the odds are really 6 to 1. There's a discrepancy. Likewise, the odds of a 8 through 12 are actually 5 out of 36. And no. 36 would be 15 out of 36. And we get paid 1 point. So we get paid as though it was even money when the odds are actually less than even money. Anyhow, that's how it's paid out. If you think about it, 7 is the most likely combination that you're going to roll on the dice, because you can, if you counted the possible outcomes, you'd notice that there are 6 outcomes where you roll a 7. Where, for example, to roll a 2, there's only 1 outcome, both of them 1s. Likewise with a 12. All right. So that's the rules of the game. Let's compile it and look at it. All right. Compiles cleanly. And when we run this, it works like this. You start out with 100 points. You make your choice in a drop down. So I'm going to pick, I'm feeling lucky. I'm going to pick 7. And I roll it. Oh, and I rolled 4 and 5, which is high. So I lose. So I'm down to 99 points. I'm going to pick low this time. I roll it. It's high again. I lose, and I'm down to 98 points. I'm going to pick 7 this time. And I got 7, so I'm up to 104 points. So you see how this game works. Now, not everything is in the high-low GUI. I hope you noticed that when we looked at the classes. There's a bunch of these classes. There's a user interface, and then there's the components of the game. All right. Let's look at the classes we have here. Here's the GUI. Here's the components of the game, the high-low game. Here's the dice. When you use those, or rather, here's the dice. And so we have 3 classes involved: the dice, the rules of the game, and the GUI. we don't put everything in the GUI. Why is that a bad idea? It's a bad idea because we might want to use this logic in a different place. Let's imagine that this was something maybe, maybe more common than the high-low game. Let's say it was a shipping calculation of how much it costs to ship something from point A to point B. If we put that in the GUI, then that would be the only place we could use it. All right. Instead, we put it in its own class. That way we can put that class in any place we need to do a shipping calculation. That object and those classes are available to make objects and to do the shipping calculation. Same thing here. If we had another game, if we wrote a Yahtzee game, we would not have to create the logic for a dice because we have already had our dice object in this game. That's what I mean by unit testing and system testing. Unit testing is me saying, I have a dice object. How do I prove that this object works? Well, let's look at the dice object. It's simple enough. It has the value of the dice as an attribute. The constructor for it allows us to roll a dice. As soon as we create it with a value. Roll, then randomly selects a value between 1 and 6 and returns the face value. Get simply returns the face value without rolling it. All right. Now, how do we check to make sure this logic works? This looks like it works, right? I mean, I could go and I could run this and say, okay, I got a 1, I got a 5, I got a 3, But how do you know for sure it works? Well, that's very difficult to tell when you're talking about random numbers. All right, because if I roll it 6 times, I'm not going to get the 6 different numbers. I might get 3 of one, 1 of another, 2 of a third, and none of the other 3. And that's okay, because that's how probability works. It's not always even distributed for a small number of rolls. But if I make a bunch of rolls, then I can test the dice to see if it works. So I have this class called dice test. And all it does and I could have written this differently, I know. But all it does is I have 6 counters for the value 1 through 6. I create a dice object. I roll that dice 10,000 times. I can do that. Now it'll still run in a second because 10,000 is nothing for the computer. It will roll the dice and it will increment the value of the counter depending on what I've rolled. So if I roll a 1, it will increment counter 1. If I roll a 2, it will increment counter 2, and so on down the line. When I'm done, I print out the values. All right. And guess what? For 10,000 times, I should have it where roughly 1/6 of the time are each of them. Let's make it an even number. Let's make it 12,000 times. So I should be getting approximately 2,000 of each. All right, because there's 6 possibilities. So I'm going to run it. And do I get 2,000 of each? No, that's not how probability works. Do I get to close to 1,000 each? Yes, I do. There's less 1s, but there's more 5s and 6s. If I run it again, all right, I should expect to see that there's roughly 2,000 of each of them. And if you notice, the one that gets the highest occurrence and lowest occurrence changes from time to time. In the first few rolls, ones and twos were the least number. Now they're the highest number. I could actually do this even better and do 120,000. The more rolls that you get, the closest it's going to be to a even distribution, but it's never going to be exactly an even distribution. And we could do this on and on. For 1.2 million rolls. And again, there's close to 200,000 each. All right, so I'm pretty happy with my dice, that the dice works. All right, so now, if there's a problem with my code, I can fairly well think it's probably not the dice's fault. I've tested the dice code, all right, and it works. Now, let's look at the rules class. The rules class is called the high-low game class. And I open it up. I have a method called play. This class creates two dice. It has a method called play. When I do play, I give the choice. And the choice is an integer. I could have done this as an enumeration and made it maybe a little clearer to read, but I did it as an integer. Our choice can either be 0, 1, or 2. 0 means that I've picked low. 1 means I picked 7, and 2 means I picked high. I also have an amount to bet. Now, in my particular game, I'm assuming that I'm betting 1 point each time. So I give the user's choice and a bet. It goes through. If the value is not within this range, I throw an exception. I could probably check to see if the bet was positive and throw an exception for that. Okay, let's do it. I roll the two dice, I add them together, I set the payoff to 0. If I picked low and it's less than 7, I've won. If I picked low and it's not less than 7, I lose, however many times my bet. If I pick 7 and it's right, I get paid 4 to 1. If I pick 7 and it's wrong, I lose a point, or 1 times the bet. Likewise for 7. I then return the payoff. So I'm either going to return a 4, a -4, a 1, or a -1. I have a method to get the values of the dice, and that calls the get method, which returns the value of the dice without rolling. Now, how do I know this class works? Well, I wrote a test class for this class. And it's called high-low game test. And what this does is it shows me, I don't know how many times it runs through, but I can go through and verify it did it correct. Let's look at the first example. I picked 1, I picked 2, and which is above 7. and I rolled a 4, so I lose. I rolled 11, but I picked low, I also lose. I rolled an 8 and I picked above 7, so I win. I rolled 10 and I picked high, so I win again. And so on down the line. And we can run through enough of these examples that we can examine them, you know, by ourselves and look and verify we're getting the right results in this game. All right. Now you can write this any number of ways. I did this. I ran through 100 games. I randomly generated a pick. And I rolled the dice. I could have actually written this another way to have 3 loops and do 100 where I picked low, 100 where I picked 7, and 100 where I picked high. So I could have done that instead of having a random number generator. And then I look at the output and verify that it's producing the correct results. So that's what I mean by unit testing. If there might be different programmers, there might be different developers working on each of these classes. And then there might be someone who brings it together and makes the whole game work. All right, in that case, before you turn over your class and say, this is done, you're not just going to eyeball it. You're not just going to compile it and make sure it compiles cleanly. You're going to look, you need to look at results and make sure you get the results that you're expecting. So you should write a unit test for your piece of the puzzle. So I did a unit test for dice. I did a unit test for the game logic. Now I brought everything together and I'm going to test the GUI as a whole. And I do that by actually running high-low GUI, because that's everything. That's my business logic classes or my logic classes, and this is my GUI class, my interface class. And I can run it, and I can, as a tester, I can run a bunch of tests and see if it gets it right or not. All right. How many should you run? I don't know. You should choose each one of them and show that you can win and lose. So I might run a bunch of lows right off the bat. And there I won when it's a low, won when it's a low. There I lost when it's high, and there I lost when it's 7. That's correct. I might then move on to picking 7. I lost when it's high, lost when it's high, lost when it's low, lost when it's low, lost when it's low. Finally, I win when it's 7. And then high. I'm going to make sure I can both win or lose. All right, I lost with a low, won with a high, and lost with the 7. All right, let's see how the GUI works to put everything together. We're going to start this today and we'll finish it next time. Or maybe we'll get far today. I don't know. We have about 5 minutes left. All right, here we have our usual classes. We have our J-frame. I have a label for the points, a label to make a choice. I initialize the points at 100. Notice that these are attributes, so these can be accessed anywhere throughout this class. I create a string array for options. I've created a combo box using that option array. What's a combo box? It's a drop down. I've created a button to play, a label for each of the dice, a label for the results. I created the game object, and we'll ignore this for now. And here's my main. My main creates a new instance of high-low. I set it visible. I say when the window closes, the application ends. I create a new panel. Actually, I create two new panels. One that contains, we'll see what this contains, and one that contains my choices. And I associate the action listener with this. What does that mean? It means that this JFrame implements action listener, and therefore it will have within it an action perform method. That's the code that will execute when we click the button. I add to the first panel the number of points. I add to the second panel the label for the choice, the drop down, and the button. I add that P choice panel, and then I add the results to the main panel. I create my two dice. I create a panel for the dice that I also add to the main panel. I set this to be oriented vertically, which means all the little panels are going to be oriented vertically, but each sub panel is going to be oriented horizontally. I set the number of points, and then I'm off. I make my choices and it runs action performed. Notice there's no dice. There's a label for dice, but there's no dice objects in this. Why? Because they're all part of the game object. Notice there's no code in here that says if I rolled, add the two dice together and see what I picked and compare that. All that logic is in high-low game. So in action performed, I get the choice that the user made, and I subtract 1 from it. All right, that's because this is, the number it's going to give me is 1 higher than the number that the object uses. I'm going to call the method on the game. We're going to assume the bet is $1. My payoff equals my game object's play method, which we saw before, and we give it the 2 arguments that method needs. What my user choice is, which is 0, 1, or 2, and how much I bet. If the payoff is negative, then I've lost. If the payout is positive, then I've won. I add my payoff to the number of points I have. I set the points label. I then do this little trick, not a trick really, but a little bit of coding to set those images equal to the appropriate dice image. I concatenate D with the number of the dice.jpg. If you look in this folder, notice that there is a file D1 through D6. So it's going to take the name of the value of the dice, concatenate with D, then .jpg, and it will open up this. That way we get the image of the dice also when you throw it. That's why we get this right here. All right, we're going to go over this again Monday because I wrap things up kind of quickly on this. So I'm going to go over the processing of it next time. But recall, the one thing I want to emphasize here, besides the new things that we have an option list that we never had before, is the fact that I'm using other objects to do the work. This is the interface. All the interface object does is it takes in the user's input, calls the appropriate classes, gets the results, and displays them. So that's all the user interface does. It shouldn't have any rules of the game anywhere within it. Likewise, when you do your assignment, you have to add pizza objects, or you have to do a calculation of an order. And you could just assume one order on the perform. You're going to create a pizza object every time they click the button. You're going to add that object to an order. And then you're going to ask the order, what is the total cost of you? What is the total cost of the order? And what is the bake time for the order? Now, in order for that to work, order that you create has to be an attribute because it needs to stick around and be accessible everywhere throughout your application. Okay, anyhow, we'll come back to this next week and we'll look a little bit more on forms. That's all I had for today. If there's no questions, we'll either see you next week or in lab.